Hi everyone, in this video we are going to learn how to calculate the trigonometric ratios of angles which are in the fourth quadrant. For example, angles like 360 degree minus theta. And also if you can imagine, the 360 degree minus theta will also be equal to negative of theta, and we'll show that in the diagram. But in the title, as you can see, I have noted that 360 degree minus theta is also equal to negative of theta. From the concept of unit circle and trigonometric function, we know that if we have a point P on a unit circle, then the x-coordinate of that point would be represented by the cosine function of the angle theta that OP creates with the positive x-axis. And similarly, the y-coordinate of the point P will be represented by the sine function of the angle theta. Using this concept, we are going to try and calculate the trigonometric ratios of angles like 360 degree minus theta in terms of the trigonometric ratios of this acute angle theta. So let me plot a point Q which would be on this unit circle in the fourth quadrant, and OQ will create an angle 360 degree minus theta. So let me first plot that point. So I have plotted a point Q on this unit circle. Q point is in the fourth quadrant, and the OQ line is actually creating an angle 360 degree minus theta with the positive x-axis. So now, as you can see in the diagram, the angle AOQ is also equal to theta degree, because if we add that with our 360 degree minus theta, then the entire angle will be one complete angle, that would be 360 degree. So definitely angle AOQ is theta degree. Now if you look at these two little right triangles, the first one is OAP and the second one is OAQ. If you look at those two right triangles, you will see that they have their hypotenuse of equal length because it's the radius of this unit circle, and then also they have this one angle which is the theta angle. That angle is of the same size, the angle AOP and the angle AOQ. And similarly, the other angle which is the angle OPA and the angle OQA, those two angles will be 90 degree minus theta, because each of these triangles are right triangle, and if one of the acute angle is theta, then the other one will be 90 degree minus theta. So for these two triangles, we see that their hypotenuse is of equal length and the two corresponding angles are also of equal size. That means these two triangles are congruent triangles. We can say that using the angle side angle axiom of congruence. So we can clearly see that the triangle OAP and the triangle OAQ, both of them are congruent triangles. So can we write it like this? So I have noted that the triangle OAP is congruent to the triangle OAQ. Now because the two triangles are congruent, their corresponding sides would also be equal. So we can say that AP would be equal to AQ, and obviously OP and OQ are also equal because they are the radius of the same circle, and the side OA is a common side between them. Now let's also make a note that this angle, the positive angle that OQ has created with the positive x-axis, that positive angle is 360 degree minus theta. However, if you consider a negative angle, if OQ had to create a negative angle with the positive x-axis, then that angle would be negative of theta. So let me denote that with a blue color here. So the positive angle 360 degree minus theta is also equivalent to a negative angle of negative theta, right? Negative angle of theta degree, which is negative theta. So what would be the x-coordinate of the point Q? Well, x-coordinate would be equal to the cosine function of the angle 360 degree minus theta. That's what we know from the concept of unit circle and trigonometric functions. Cosine of the angle represents the x-coordinate, sine of the angle represents the y-coordinate. So in this case, let's get started with the cosine of 360 degree minus theta. So we can write it like this. So here I have noted that cosine of 360 degree minus theta is equal to the x-coordinate of the point Q. So what is the x-coordinate of point Q? Well, that distance would be the OA distance. So can we write it like this, that this will be equal to the OA distance, and of course now we are talking about positive x direction. So I am writing as positive OA. And then what is OA? Well, OA is actually x. It's the positive x. As you can see up there, OA is actually positive x, and also that is equal to positive cosine of theta. So from here we got two things, that the x-coordinate of Q is also positive x. So I'm going to fill in the blank right here where I had left an empty parenthesis there. So I'm putting x. So the x-coordinate of Q is also positive x. And also we see that the cosine of 360 degree minus theta is actually equal to positive cosine of theta. So let me make a quick note here. And while making this note, I also decided to include this one other situation where if the angle is negative theta, then also it will be same as cosine of 360 degree minus theta. It will be same as cosine of negative theta. And that value is actually cosine of theta, positive cosine of theta that we have just derived. So now let's try to derive the y coordinate of the point Q. Well, y coordinate of the point Q would be the sine function of the angle 360 degree minus theta. So let me write that down. So if you think about it, what is the y coordinate of Q? Well, that distance is actually the AQ distance, but that will be in the negative y-axis direction. So it will be a negative value. However, the absolute distance is the AQ distance. So can we write it like this? So I have noted that this is equal to negative of the absolute value of the AQ distance. Now what is AQ again? Well, AQ again is equal to AP. As you can see up here, I'm doing a green underline. AQ is actually equal to AP. So here we can then say that okay, this must be, again I maintain the negative sign, then I can say okay, this must be equal to the AP distance. And then what is AP? Well, if I scroll up, you will see that AP is actually equal to sine of theta, positive sine of theta, and that is again equal to positive y. So I'm going to put those two values here. So this will be positive sine of theta and also equal to y. So this will be equal to, I maintain the sign, and then AP is actually sine of theta. And again, I maintain the sign, sine of theta is actually equal to y. So we have found out the y coordinate of the point Q, and that appears to be negative of y. And I already had a negative sign here in the empty parenthesis, so I am simply writing a y in green color there. So now we have filled in the blank for the coordinates of the point Q. So the coordinates of the point Q are x, negative y, when x and y are the coordinates of the point P, which is in the first quadrant on this unit circle. So from here we have also found out that sine of 360 degree minus theta is also equal to negative of sine of theta. So let me make a quick note. Now that we have calculated the cosine and sine of 360 degree minus theta, we should be able to easily calculate the tangent of 360 degree minus theta. And we know that tangent is actually the ratio of sine over cosine. So this should be sine of 360 degree minus theta divided by cosine of 360 degree minus theta. Now what is the value of sine of 360 degree minus theta? Well, that is actually negative of sine theta. And then what is the value of cosine of 360 degree minus theta? Well, that is actually positive of cosine of theta. So this is going to be a negative value, and it is sine over cosine, so that would be negative of tangent of theta. So let me make a quick note. Next, let's try to calculate the cosecant of 360 degree minus theta. We know that cosecant is the reciprocal of sine, so we can write it like this. And what is the value of sine of 360 degree minus theta? Well, that is negative of sine of theta. Now this is going to be a negative value, and 1 divided by sine of theta, that is actually reciprocal of sine, that would be cosecant. So this would be negative of cosecant of theta. So let me make a quick note. Now let's calculate the secant of 360 degree minus theta. Secant is the reciprocal of cosine, so we can write it like this. And what is the value of cosine of 360 degree minus theta? Well, that is actually positive cosine of theta that we have already derived. Now we see that this is turning out to be reciprocal of cosine of theta, so that would be secant of theta. So this is a positive value, it would be secant of theta. Let me make a quick note. Now we are left with the last one, which is the cotangent of 360 degree minus theta. Let's calculate that. We know that cotangent is the ratio of cosine over sine. So we can write it like this. And what is the value of cosine of 360 degree minus theta? Well, that is actually positive cosine of theta that we have already derived. And what is the value of sine of 360 degree minus theta? Well, that is actually negative of sine of theta. That also we have derived already. Now from here we see that this is going to be a negative value, and cosine over sine, that would be cotangent. So this will be negative cotangent of theta. So let me make a quick note. So we have derived all of the trigonometric ratios of this angle 360 degree minus theta, which is also equivalent to negative theta. Hope everything made sense. Thank you for watching. See you in the next video.